All right, hello everybody and welcome to Unit 2. We're going to start with particles in motion. So particles are in constant, let's try that. There we go, constant random motion. Okay, so particles are always in constant random motion, and the particles move in straight lines until they collide with another particle or the container wall. So the particles are going to move in straight lines until they collide with another particle or those container walls. Okay, so these are just, we're talking about our little particle pictures that we have been drawing before. So in our particle pictures, we're going to be bringing those back with this unit, and the motion of the particles are represented with whooshies. Or you might also see later as whooshies. And so what we do is our whooshies, we will go ahead, let me draw it, I'm going to draw it on this side over here, but so here would be our particle, and we're going to indicate that it's going with a little whooshy. That would just be a straight line there. And how that goes is we would go ahead and say that our particle is moving in that way. So sometimes you'll see particles with the whooshy like that, or you may even see them with an arrow that tells you in the way that they go, which would still mean that they go this way. For the most part in class, we're going to draw our particle pictures with the whooshies as in the first way I have drawn them. Okay, so we have energy is our next thing, because as our particles are moving, there's going to be energy that's going to be happening with them. So energy is a quantity that has the capacity to cause change and is conserved. So energy is a quantity that has the capacity to change and is conserved. Okay, just kind of like with our law of conservation of mass, where mass is not created or destroyed, it's just going to be rearranged in there. Energy is the same way. You're not going to create it and you're not going to destroy it, but it is always going to be conserved. And so how it can be conserved is that energy is transferred from the collision of particles, so when they're bumping into each other. Collisions are elastic, which when it's elastic, it means that there is no energy loss. And the energy can change the speed and the arrangement of particles. Oops, not seep. So that's arrangement. So energy can change the speed and the arrangement of particles. In this unit, we're going to be focusing on the motion of particles. So that's where we're going to really kind of focus, keep our focus for this unit. So a type of energy is thermal energy, and thermal energy is the speed of the particles. And you will see this represented as ETH. Okay, so you see it as the capital E with the little subscript TH. And in particle pictures, the speed of the particles is going to be represented with the number of whooshies. Okay, so more whooshies equals faster particles. Okay, so if I go ahead and I have two particles here, so let's go ahead. We'll draw one right there. We're going to draw one right here. And so now let's say I have this one and I have this one. Which particle, A or B, would be moving faster? All right, next up we have temperature, which is a measure of the thermal energy. Okay, or the speed of particles. Okay, so you're going to see how thermal energy is also temperature is kind of a measure of that thermal energy that's going in there. So as the temperature increases, the particles will move faster. And as the particles move faster, they have more energy. And therefore they have more ETH. Okay, so temperature is a measure of that thermal energy, or the speed. So as that temperature increases, the particles move faster. So go ahead and you can think about this as what happens if the particles are going to, what's going to happen to the temperature of the particles as they start to slow down. What would happen to that temperature? So the faster the particles move, the more energy they have. And so if they're moving faster, then that thermal energy will increase. Okay, so last up we have our Kelvin, which is an SI unit that measures the motion of particles, or the temperature. Okay, so it's measuring the motion of the particles. So you can hopefully start to see how these are all interrelated to each other. So it's just a measurement of temperature, and I'm sure you guys have heard of the Kelvin scale before. And sorry I'm writing so painfully slow and that this is thin. They updated this on me since the last time I've made one of these, and so it's all kind of crazy. So anyways, so S Kelvin measures the motion of the particles. So again, it's a measurement of temperature. And remember, temperature is a measure of that energy, the thermal energy. Kelvin has the symbol of K. And what's really important about Kelvin compared to any of the other temperature scales that we have there is that it is an absolute scale. And so when you actually have 0 Kelvin, or absolute 0, okay, that is when there is no more motion of the particles. Those particles have stopped moving. Okay, and unlike when in like 0 degrees Fahrenheit or 0 degrees Celsius, when those reach 0, it's not necessarily the absence of motion. That is just a 0 of their scale right there. But the Kelvin scale is an absolute scale, and you have your absolute 0, which is no motion of the particles, or 0 Kelvin. Any of the calculations that we do in class will need to be in kelvins. And that's one of the ways that we do like to kind of trick you, is to put your temperatures in degrees Celsius. So you will have to know a easy conversion factor to get your numbers from Kelvin to degrees Celsius. And it's basically Kelvin will equal whatever your degree Celsius is plus 273. Okay? So that is something that we will expect you guys to know. So for example, if you have 25 degrees Celsius and we want to figure out how many kelvins that is, You just go ahead and plug it in, so we know Kelvin equals our degrees Celsius, which would be 25 degrees Celsius plus 273. And if you plug that into your calculator or you do it in your head, you will realize that that is 298 Kelvin. Okay. Make sure, just to the right, that you draw those before and after pictures of the gas being heated. So remember, so those particles, think about how they will be before they are heated, and then think about how they will be after they are heated. Think about those numbers, and then think about that energy, so what happens before they're heated, and then draw that after they're heated, so show that energy by their number of whooshies. And that's about it. So once you've done with that, then go ahead and write that 3 to 4 sentences, identifying the main points of the notes, and you guys are done. We're just going to do little eyeballs for the day. That's kind of a funny looking smiley face, but we'll go with it.